Alright everyone, welcome back to these tutorials. This video is a part of the Exponents and Radicals series, and today it is part 3 of Exponents and Radicals. In this video we are going to be basically just going over integral exponents, which includes exponent laws, and also negative exponents, which are two very important concepts in this unit. So, there are a few different exponent laws. In total, there are 6. So, starting off with product of powers, what this basically means is product, which means the result of multiplication of powers. So, if we have x to the power of a times x to the power of b, this essentially means if the two bases are the same, then the exponents will add. So this will end up being exponent x to the power of a plus b. But if the bases are different, like let's say we had x to the power of a times y to the power of b, this will literally just end up being x to the power of a, y to the power of b. This will not be x to the power or xy to the power of a plus b. That is only if the bases are the same. Alright, now if we have quotient of powers, which is when powers are divided, they subtract. So if we have x to the power of a divided by x to the power of b, this will end up being x to the power of a minus b. So if a was 3 and b was 1, then it would be x to the power of 3 minus 1, which would be x squared. But again, this is only if bases are the same. And now if we have power of a power, so for example, it would be like x to the power of a, and then all of that to the power of b, those two would multiply. Then it would end up being x to the power of a times b. Okay, so if we had x to the power, or x squared to the power of 3, this would end up being x to the power of 2 times 3, which would be x to the power of 6. Now, if we had power of a product, this is basically if you have a product to the power of something. So, let's say in brackets you had a times x times y, all to the power of, let's say, b, then that would mean that the power outside of the brackets is applied to every single term. So this would end up being a to the power of b times x to the power of b times y to the power of b. Now, if we had power of a quotient, so x over a to the power of b, same concept as power of a product. That exponent, since it's outside of the brackets, that exponent gets applied to everything in the brackets. So this would be x to the power of b divided by a to the power of b. And now lastly, zero exponent, which is pretty simple, and it's anything to the power of 0 equals 1. So if you had x to the power of 0, that equals 1. If you had x to the power of a to the power of 0, that equals 1. If you had power of a product be x to the power of a and that whole thing was to the power of 0, that equals 1. If you had b times x to the power of a to the power of 0, since that 0 exponent only applies to what's in the brackets here, so it applies to x to the power of a, this becomes b times 1, because x to the power of a all to the power of 0 becomes 1, then it just becomes b. Okay, so let's do some practice questions, and for every single one of these questions, I want you to pause and try to figure it out by yourself. So let's start with a to the power of 8 in brackets multiplied by a to the power of negative 4. So since what's in the brackets can't really be simplified any further, this becomes a to the power of 8 times a to the negative 4, and that is one of our exponent laws, the product of powers. So what this will become will be a to the power of 8 plus negative 4, and that gives you a to the power of 4. Let's say we have 6 to the power of 5, all to the power of 4. So then these exponents will multiply. So this will end up being x to the power of 5 times 4, which gives us 6 to the power of 5 times 4, which gives us 6 to the power of 20. So for this question, let's say we have 6 times a to the power of 0. So from your zero exponent laws, you know that a very important thing about exponents is you have to pay attention to brackets and what the exponent is being applied to. Since there are literally no brackets in this case, that zero exponent is only being applied to this a. But if it looked like this, that 0 would be applied to the 6 and to the a. So just make sure you're paying attention to that. So 6 times a to the power of 0, this gives us 6 times 1, which gives us 6. Let's say for this question, we have 2b to the power of negative 2 to the power of 3. This is our power of a product exponent law, which means that 3 exponent gets applied to every individual base in the brackets. So this then becomes 2 cubed times b, and then the negative 2 and the 3 multiply, and you get b to the negative 6. You can simplify 2 cubed, and that gives you 2 times 2 times 2, which gives you 8, b to the negative 6. And then the last question has more to do with our next section that we're going to go over in a few seconds, which is negative exponents. So we have 4 to the power of 0 divided by 4 to the power of negative 3. And we can write this in this form, 4 to the power of 0, 4 to the negative 3. And there are two ways to go about this. You could either say, oh, well, exponent law, quotient of powers, right? And you could be like, oh, well, this means 4 to the power of 0 minus negative 3, which gives you 4 cubed, which is correct. But there's another way, and you could also say, well, hey, 4 to the power of 0, doesn't that mean that equals 1? And that is correct. This would give you 1 over 4 to the power of negative 3. And what you're going to learn in a few seconds is that this 4 to the negative 3 can actually become a 4 to the positive 3 if these are flipped. So this could become 4 cubed over 1, which gives you 4 cubed. But that we are going to go over right now. All right. So let's begin with negative exponents. So an important thing to remember is bases and fractions are very important when it comes to negative exponents. So let's just list some out. Okay, so let's say we have 2 squared. That gives you 4, obviously, right? If we have 2 to the power of 1, that just gives you 2. If we have 2 to the power of 0, as we just learned, that gives you 1. But if you have 2 to the power of negative 1, this actually means 2 to the power of 1 is a denominator. That's what that negative sign means. So this actually means, since it's a denominator, 2 to the power of 1 is 2, and there's a 1 on top. So this gives you 1 over 2. Similarly, with 2 to the power of negative 2, that means 2 squared is a denominator. So this means 1 over 2 squared, which gives you 1 over 4. And then same with 2 to the power of negative 3, 2 to the power of negative 4, 2 to the power of negative 5. If it just means 2 to the positive of that power is a denominator. So a form to remember this is if you have a over b to the negative n, if you flip the numerator and denominator, that gives you the positive exponent version of this. So then this becomes b over a to the positive n. And the same thing with this. If you want to make this a negative exponent, you just flip these bases, and then it becomes a negative exponent. So for example, if we have 2 over 3 to the negative 3, if we wanted it to be positive 3 instead of negative 3, then this is the same thing as 3 over 2 to the positive 3. We just flipped the numerator and the denominator. And this gives you 3 to the power of 3 is 27, 2 to the power of 3 is 8. Let me go over a few questions with you, just so you can deepen your understanding. Let's start off with a simple one first. 5 to the negative 1. This just means 5 to the power of 1 is a denominator, so 5 to the power of 1 is just 5, and it's 1 over 5. If we have 5qm to the power of negative 3, again, as I said previously, it's very important to pay attention to what exactly the exponent is being applied to. So since there's no brackets or anything, that negative 3 exponent is only being applied to that m. So this means it's 5q m to the negative 3. If we want to write this in the form of a positive exponent, it's 1 over m cubed. So then this can become 5q over m cubed, because the 5q multiplies with the 1, becomes 5q, and then the invisible 1 denominator here multiplies with m cubed, and that just becomes m cubed. 2 over 5 to the power of negative 4, and we want to write this in the form of a positive exponent. This just becomes 5 over 2 to the power of 4. And that will, if we simplify it, give us 625 over 16. And now we're going to do one more, and this one's a little bit trickier. So if we have negative 2a to negative cubed times b times c to the negative 8, and we want to write this in the form of a positive exponent. Again, you have to pay attention to what the exponents are being applied to. So negative 2 is fine. There's no negative exponent there. So we have negative 2. But then a has a negative 3 exponent applied to it. But we want to write this in a positive exponent form. So then this becomes 1 over a cubed. Alright, and then we have b, which no exponent applied to it, so we can keep that the same. And then we have c, which has a negative 8 exponent, so then this becomes 1 over c to the power of 8. And then we want to simplify it. So negative 2 times 1, let me just draw a line here for the numerator and denominator. If we have negative 2 times 1, write this here, and then on the bottom we have a cubed. And then we have times b times 1, and then over c to the power of 8, and then this just becomes negative 2b over a cubed c to the power of 8. Alright, so that basically concludes our video of Exponents and Radicals Part 3, and I hope you found this video helpful, but I will see you next time in the final part of the Exponents and Radicals series.